All right, folks, just want to show you how to do some of these motion problems. Just kind of a review of all that we've done over the past week. The first few here are the speed problems, where the formula is speed equals distance divided by time. So they'll give you in these, some distance and some time, just to do the division for those, okay? For acceleration, it's acceleration and deceleration here. And remember, we either start at 0 or stop. Those are going to be 0 speeds for those. But the equation for this is a equals final velocity minus the original velocity divided by the time. So you have two velocities for those. And lastly, at the bottom, you have some momentum problems where P, the momentum, equals m mass times v velocity. I know m's not momentum because m's already taken by mass, so you got to use P for momentum. And on the other side, there's a few more of those as well. Okay? Now, the other problem I got for you, look pretty quick, and so are these. Won't take you long. Some collision problems. This is kind of new. This involves the elastic and inelastic collisions of two items. So you have car A going to the right and car B going to the left with their respective speeds and their mass. And that gives you momentum. So you have to find the momentum for both cars. And then when they come together, they either bounce or they stick together. And you have to see the result of that. So first of all, let's find momentum for both of these. Again, momentum equals P equals m times v. So for car A, it's 3 grams and 2. So it's going to be 3 times 2 is 6. Okay. And car B, the numbers are reversed. The mass is 2 and the speed's 3, but it still gives you 6. So the momentums are both 6. So now when they come together, for an inelastic, this is where they actually stick together. So when A comes this way to the right and it hits B, which is going this way, they come together and they stick. Well, because the momentums are equal, they're going to stick and just stay together. There's no extra momentum for either one of them. They both cancel each other out. So the two come together and stay there. Now for elastic, they actually bounce. So when they come together with their momentum of 6, the momentums transfer. B's momentum transfers to A, which bounces that way, and A's momentum transfers to B, which goes that way. So they just kind of hit and bounce each direction and continue on the opposite directions. All right, let's get another example because this one has some different numbers. A has 10 for the mass, 2 for velocity, that's 20 for momentum. B is 2 and 5, its momentum is 10, so the momentums are different. So now when they come together and stick, inelastic, well, you have 20 going to the right, that's 20. You have 10 coming to the left. Well, when they come together and stick, there's this 20 is 10 bigger than that. So the combined, there'll be one mass because they stick together, they'll have a combined momentum of 10 going to the right. This 10, which is smaller than 20, subtracts from 20. Now you have 10 momentum going to the right with both of them stuck together. The speed's not immaterial. I don't really care about the speed. Now when they bounce, again, you have 20 coming from the right, 10 from the left. When they come and bounce, the 10 transfers to the A. So now, after they bounce, A is now going this way with momentum of 10. And B is going that way with momentum of 20. They actually swap momentums, okay? All right, folks, good luck.